everyone. I'm Kyle ORGEL. I'm reporting from Reuters Energy Live here at the NRG Center in Houston, Texas. I'm here with Ron Marinzel from Energy, and we're going to be talking about small modular reactors and nuclear power in the United States and elsewhere. Thanks so much for joining me.
Absolutely, thank you.
Awesome, awesome. So I think the first thing I want to start with is the small modular reactor itself that you're working on. You have the XE100 model.
Correct.
Can you tell us a little bit about it and where it is at today?
Sure. The XE100 is Energy's small modular reactor, as you stated. It's a high-temperature gas reactor. We use helium as the working fluid, which has a lot of really terrific thermal characteristics. The reactor itself is it's based on TRISO fuel, which is a little bit of a novelty. We manufacture the TRISO fuel ourselves in a factory in Oak Ridge, Tennessee. In fact, we've just recently started construction on a commercial scale capability in Oak Ridge. So we will be not only producing TRISO fuel for our XE100s, but also for other reactor companies that use TRISO fuel.
Awesome. So TRISO fuel is used in other reactors itself.
It can be, right.
It can be. The innovation here is really the size. It's really about the small size of this reactor.
Correct.
Right?
Correct.
And I think that leads into the next question. It says online that it's also a passive reactor. Can you explain what that means to the layman?
Yeah, the passivity means that there are far fewer safety systems, and those safety systems, in order to be engaged, it happens in a natural or a passive fashion. No operator action is required in order to shut down the reactor in case of some type of catastrophic failure.
It stops on its own.
If you read our website, it's physics,
yes,
not operator actions that shut down the reactor in the case of some kind of an anomaly.
Right.
So that's the passivity.
And this is probably one of the critical elements in nuclear reactor design is these safety elements. This has got to be one of the biggest innovations, not just to deal with the public pressures and concerns, but the actual safety of the units themselves.
Correct.
Right.
Actually, though, it is an innovation, but it's not new technology.
Interesting.
Yes, the tristructural fuel, TRISO fuel, has actually been around for 50 some odd years. It was pioneered at the Oak Ridge National Laboratory, and it was not perfected, but it was used in Germany in a variety of reactors. And there's actually one Chinese reactor operating today that uses TRISO fuel. The innovation has come with the fabrication techniques. They're much more pure, there's much less waste. Our ability to economically produce TRISO fuel at scale. Anything has to have an economic foundation to it. You could have the coolest technology, but if it's not commercially viable or not able to be sold at an economic price, then you're struggling. And that's where the innovations have really come the last 10 years, I would say.
Okay, and you mentioned the economics. I'd love to just turn to the financing part of this as well. Of course, things don't work if they're not economically viable. What are the financial backings for a project like this that's so capital intensive, material intensive?
Yeah, well, fortunately, the U.S. government stepped in a big way for us. There is a Department of Energy program called ARDP, Advanced Reactor Demonstration Program, and that was an effort on the Department of Energy's part to galvanize the American reactor community, so to speak. DOE had two awardees for that. One was Energy, we were very fortunate, and the other is TerraPower, which is the company owned and founded by Bill Gates. So both of our companies are off and running, building commercially viable reactors.
That must have been quite a prize to be one of the recipients, and now to be a big in a bit of a race, I suppose, with your other competitor.
I guess
a friendly race.
Sure.
Okay.
But there's so much demand. Right now, we're pulling for anybody in the nuclear industry to succeed.
Yeah, and on the environmental sustainability side, I would have to concur with that. One of the other technical questions I'd like to ask you about is the startup time for nuclear power. I think it's generally perceived as a firm baseload energy supply source, but maybe maybe it's not so flexible to changing demand. Can you just respond to that impression?
Yeah, ours is very flexible. We are able to increase or decrease our output. They call that load following. Some of our use cases involve maybe a solar source or a geothermal source during the day, and then followed by nuclear in dark hours and so forth. But by and large, we're designing this and implementing it to be used 100%. This is a huge investment. You don't want to run a nuclear power plant at 60% parts of the day.
Right.
You know, you want to take advantage and exploit the economics associated with this technology and the investment.
Right, of course. That's so fascinating. And one of the other elements I wanted to talk to you about is the environmental consideration. Can you talk to us about where the waste goes? Can it be reused? Where is it stored if not?
Yeah. So waste is a problem that we've had for 50 years in the nuclear industry. Nothing new, right? We are optimistic that the current administration may come up with some kind of a long-term storage. Obviously, we had the Yucca Mountain project for years that was never really brought to fruition. And currently, every one of the 94 operating nuclear reactors in the United States store their spent fuel right on site. So as you drive past a nuclear plant, there's actually spent fuel there as well. There are some companies that are looking at interim storage, which is 100 years or so. But by and large, I think the spent fuel, it's really not as big of an issue. It's safe. We have very strong procedures and so forth in place to store it and transport it safely. So I think we're going to come up with a long-term storage solution at some point.
Yes, and I think for those out there who have seen pictures online of a storage facility with depleted uranium, you can't help but be shocked by how little space it takes.
Yeah.
You may have been to a big box store that was larger than a nuclear waste disposal facility.
Absolutely.
So, one more question for you before we wrap up. Do you have any advice to the young generation out there trying to get into the energy industry, who's fascinated by these new technologies, battery storage, nuclear power, environmental sustainability? What advice would you give to the young generation, especially the kids coming out of college right now?
Well, explore, right? And take your physics and chemistry and math classes as well. Now, actually, one of the neat things, we at X Energy, we do hire people in those highly technical fields, but we also hire people in procurement. Obviously, supply chain and going out and finding competitive suppliers and vendors is a big part of our company. HR is a big part of our company, keeping our staff, not only finding them, but then retaining highly specialized employees. So it's an excellent industry to be in right now. I'm a little biased, obviously, because of X Energy, but the nuclear industry is, I think, at the very beginnings of a very long and prosperous future.
Yes, and it's a very exciting time from an environmental sustainability standpoint.
It really is.
The energy system changing.
And you know what? We have not even mentioned carbon-free. This whole interview, we haven't even talked about
I think I've just, it's such a given. I forget to say it to the audience.
You forget that one of the overwhelming aspects of this is that it's clean generation of power.
Right.
So you can do it without any, adverse weather conditions or climate and so forth, and, which are becoming more and more of a concern every single day.
Ron, thank you so much for your time.
Thank you very much.
Have a great rest of your show.
Excellent.
Awesome. Thank you very much. Thank you.